Okay, so what about experiment number 2? So now let's ask, what happens if the wage increases? Okay, so let's draw it. We'll do it graphically first here. So here's my, if I work, or I consume all of my leisure possible, I get pi minus t. But now if the wage increases, what happens is the slope of this segment will increase, right? This now says that I can consume more consumption, or I receive more consumption for each hour of leisure I give up because the wage is higher. And now here's my initial utility curve. And I'm going to claim now that it's unclear what will happen to consumption, okay? And the reason is because, it's clear what will happen to consumption, it's unclear what will happen to leisure, or to hours worked. And this is why. Is because there are two effects, okay? So one is the income effect, which says that my income will now be higher for any amount of hours worked. So this is like an increase in income. And because consumption and leisure are both normal goods, when my income goes up, I consume more of both. So this leads consumption to increase and leisure to increase. But there's also this substitution effect. And that says leisure is now relatively more expensive. So recall that we said that the price of leisure is W, the wage. Or put another way, and this is the same thing, consumption is now cheaper. Okay, so I now have to give up fewer leisure hours to consume any given amount. So it's now cheaper for me in terms of leisure to consume. And so therefore, it should be optimal for me to substitute towards the cheaper good. So this effect leads me to consume more, but to have less leisure, because leisure is now more expensive. And so in total, we can put these in a table, for example, here. So what are the effects here? So we have a substitution effect. And the substitution effect says substitute towards the cheaper good, which is consumption. Then we have the income effect, which says because both goods are normal, consume both. But then what's the overall effect? I'll put this in red. Well, the overall effect on consumption is obviously positive, but it's unclear what the overall effect on leisure is, okay? And in fact, to figure it out, we would need to know, I'll put this here, we would need to know the utility function to know which effect dominates and to know whether leisure increases or decreases when we increase the wage. Okay, so if we need to know the utility function, let's take an example here. So imagine that the utility function is the following. Is the log, the natural log of consumption plus eta times the natural log of leisure. Okay. Does this fulfill our assumptions about consumption? Okay, so does this fulfill our assumptions? Assumptions. Let's test them. So what were our assumptions? Well, first is that we like both goods. Okay, so in other words, we need that the marginal utility of leisure and the marginal utility of consumption are going to be positive. So let's see what those are. Well, the marginal utility of leisure is just going to be the derivative of utility with respect to leisure. So it's eta over L. And of course, that's positive. Marginal utility of consumption, again, is just the derivative of the utility function with respect to consumption. It's 1 over C. It's positive. So therefore, this is a check mark. More is better. Okay, what about our next assumptions, which is diminishing marginal utility? So now we need that the derivative of each marginal utility with respect to its argument We need those to be negative. So let's see. The derivative of MUL with respect to L is just going to be equal to negative eta over L squared, which is negative. And the derivative of the marginal utility of consumption with respect to consumption is negative 1 over c squared, which is also negative. So we do have decreasing marginal utility. And I'm not going to show it, but you can show that both of these are normal goods. So I'm not going to do it. It takes a few lines. Maybe I'll make it an exercise. But you can show that these are normal goods. So that one also holds. Okay, so let's move on now to the analytical solution for this. So what does the consumer want to do? The consumer wants to maximize utility by choosing consumption and leisure subject to their budget constraint, which we worked out before, is I can consume my total income minus taxes. Whoops. And now remember the conditions for optimality that we derived before. So one is that MUC times W is equal to MUL. So we've seen that a couple of times. So let's plug in the values for that then. So MUC is just 1 over C. And MUL, as we just saw in the previous slide, is eta over L. Okay, so that's condition 1. And condition 2 is the budget constraint. So those are the two equations that have to hold for optimality. I need to be consuming on my budget constraint, and I have to have this proportionality given by the marginal utilities. Okay. So let me copy these here. Bring them over to the other slide. Okay. There we go. Make them a bit smaller. Very good. So now to solve for this, let's plug 1 into 2. Okay, so notice that we can rearrange for C in 1 here. And so that just gives us C is equal to, sorry. And now let's plug that into equation 2. Okay, so plug 1 into 2. And that gives us the following. Is equal to. Okay, and now just a few lines of rearranging. So now what I want to do, I guess I should have been specific. What we want to do right now is solve for leisure, right? We want to figure out what the optimal leisure is, and we'll use that to figure out what labor supply is. Because once we know leisure, we just subtract it from total hours to get labor supply. So right now what we're trying to do is solve for leisure. So let's bring all the leisure terms onto one side. So that gives us the following. Great. And then we can factor out L and W from the left-hand side. So that gives us 1 over eta plus 1. And then we can solve for L. Over eta. Great, so that's our solution for leisure. I'm going to copy it and bring it to the next slide. Oops. Because now we're going to say, okay, so that's our solution for what the optimal leisure is. It's the optimal choice of leisure by the consumer. Now we want to know, how does it change with the wage? Okay, so remember that what we want to know is it's not obvious a priori whether leisure should increase or decrease because there's both this substitution and income effect. So to figure it out, what we want to do is we'll take the derivative with respect to wage And if it's positive, we'll know it's increasing with wage. If it's negative, we'll know it's decreasing with wage. So let's do that here. So there's going to be two terms, first of all, because wage appears twice in this equation. So the term with respect to the wage in the numerator is going to be h over the entire denominator. Okay. And then the derivative with respect to what we see in the denominator is going to be the entire numerator divided by denominator squared, and then times 1 plus 1 over eta, because that's what's multiplying the w in the denominator. Okay, and then let's take this 1 plus 1 over eta. It cancels out with one of the 1 plus 1 over etas in the denominator. Okay. Almost there. So now we have w squared times 1 plus 1 over eta. And now let's put both of these into the same terms, or into common terms. Okay, and so the way we're going to do that is multiply this left-hand term, or the left term, the first term, by w. And that's going to give us WH minus profit minus taxes all over w squared 1 plus 1 over eta. And of course, these two terms cancel. And we're left with negative pi minus t over. Great. So with a few lines of algebra, now we can evaluate whether the income effect dominates or the substitution effect dominates. So I'm going to bring this once more to the next slide. So this is our derivative of leisure with respect to the wage. And so now what can we see? Well, therefore, it's all going to depend on the numerator here, right? And so it will be positive if the numerator is negative. And alternatively, our derivative will be negative if the numerator is positive. And finally, it'll be 0 if the numerator is 0. So now let's stop for a second and think about the sort of economic meaning of this. And let's start with the case that we keep talking about, which is this one, the middle case here, where the numerator is positive. So what does this mean? If the numerator is positive, then when we increase the wage, leisure decreases. And if leisure is decreasing, that means that we have an increase in labor supply. But then the opposite is true in the case we haven't been talking about, right? So if pi minus t is negative, then that means that when we increase wage, leisure is increasing, which means that labor supply is falling. And in this final case, there's no change in labor supply. So why is this interesting? Well, you can imagine that there's a labor supply curve that's upward sloping, right? I believe that's my next slide. You can imagine there's an upward sloping labor curve, or labor supply curve. That's what I imagine you've seen before, which would look something like this. As the wage increases, I want to supply more labor. And we've seen that actually, in our analytical example at least, that's only true in one case of 3. So what's interesting about this model is you don't always get an upward sloping supply curve necessarily, although you'll find that we'll usually make assumptions necessary to get an upward sloping supply curve. So in other words, we're going to make the assumptions necessary such that the substitution effect, I'll write this here, this is the supply curve in which the substitution effect dominates. So the substitution effect is greater than the income effect. If it wasn't, if it went the other way and the income effect was larger than the substitution effect, an increase in the wage would lead me to increase my leisure and therefore work less.